Yeah, so this is a rundown of the simple XMLRPC server and client setup. So in terms of the basic requirements, the user is able to send an input to the server. So if we just boot up the server and a client. So if the user wants to send a topic, some text, and the timestamp for an entry to the notebook, the user can choose one. So for example, if we choose the topic dogs and then dogs note and dogs text, so send those to the server, and so it's going to reply with a success message, so an entry was added. And if we go look at the output, originally there was just the topic animal things, but now if we format this, we'll get dogs, topic, and the note. And if we try to append to the same topic, so let's choose new entry, topic, dogs again, but then we choose or write dogs note to dogs text to, then we'll see that it added it or appended it to the same topic. But in terms of the server's requirements, so it saves data in a local mock database in form of XML, and in terms of being able to handle multiple clients, it is a multi-threading server. So because of that, it's able to handle multiple servers, or multiple clients rather. But then onto the additional requirements. And then of course, the user, in terms of basics, the user is able to search for topics that are in the database. And then going on to the more advanced or the additional requirements, when you search for a topic, it's first going to search the database. So here it gave one entry, and then it goes on to look or use the Wikipedia API to look for more information. So it grabs like the first article, the first paragraph or two from the first matching article. So it looked for dogs and it found this, and so we can choose now to append it. So if we type yes or Y and then give it a note, so dogs note wiki, and now dog note 1, 2, and then wiki, and so basically the whole process of the communication works as follows. So the client initially sends the function call, or sends the search call to the server. It checks the database, and if it finds anything, it will display it. If not, it's just going to show an empty array. Then next the client sends a request to for the wiki search, and then the server will go to the Wikipedia API, retrieve information, and then eventually return it to the user. And then the user is able to choose whether to append it to the database, in which case the user sends it back to the server, and then the server returns with a success message. In terms of the additional requirements, that covers it. But then in terms of design challenges, I think looking at heterogeneity, so the components, they, for example, the server components, they communicate with each other through similar interfaces. So, for example, the get wiki function here. First, it looks for like all articles that might match the term that the user gives initially, and then it calls a secondary function which then makes the API request to the specific article and gets the content in that article. And so these communicate with just a string, and then if the secondary method, for example, fails, returns a 1, then it's going to like basically cascade back and just tell that the search failed, and then it's just going to give an error message back to the user. So that's like a form of failure handling. And openness, so I think the interfaces are pretty simple, and they're like pretty bare bones, so they could be switched out, and maybe a certain method or a certain component could be improved, because the interfaces are quite simple. In terms of scalability, as I said, it's a multi-threading server, so it's going to be able to handle multiple server clients. And in terms of transparency, I think going back to this graph for displaying how it communicates with Wikipedia, it's not like well, right now we're like, well, the server says that it's from a wiki, or at least I think it does, but like if you don't explicitly mention it to the user, the only way the user is really going to know that that they're going to be like transparent, that the server is in fact getting information from another source, is the time, the delay, that it's not immediate, so the user might be able to catch on and say, oh, okay, I guess it's a distributed system then. But if it weren't for the delay, then it wouldn't be obvious to the user that it is in fact a distributed system. But yeah, I think that sort of covers it. Here's the add entry function, get entry function, get wiki, get wiki content. And in terms of the user's functions, we have new entry, the user forms an object that contains a topic, node, and text, timestamp, and then that all gets sent to the server. In terms of search topic, the user determines whether if it receives a 1, then it's going to say an error occurred. If the search topic array the length is 0, then it's going to say no current entries, and so on. So the client side sort of deciphers some of these message or the codes that the server returns. Yeah, I think that about wraps it up. Thanks for watching.